Hello, I'm Anupam. Today I'm going to derive Einstein's one of the famous equation, that is equal to mc squared, that is mass energy equivalence. So before I start, let me introduce the terminologies that I have used, that is E equal to energy, m is equal to mass, c is equal to speed of light, which is constant in irrespective of any inertial reference frame, v is equal to velocity or speed of any particle, s is equal to displacement, and f is for force. So now let's start. As per Newton convention, E is equal to force times displacement, okay, and force is equal to the rate of change of momentum, that is dmv dot ds. Okay, now Newton always thought that this m, that is mass, is always constant, but Einstein has shown from his theory of relativity that mass also varies, that is known as relativistic mass gain. I have derived in one of my other video the time dilation, length contraction, and relativistic mass gain. So I will put that link to the comment box. So now from that, the Einstein has shown that m is equal to gamma times m0, where m is equal to relativistic mass, m0 is equal to mass at rest, and gamma is a special term. Gamma is equal to 1 by root over 1 minus v square upon c square, and we have seen that gamma always lies between 1 to infinite. This will not be there because gamma is always less than infinity. So now from that, if I put value of gamma in this equation, we have m is equal to m0 by root over 1 minus v square upon c square, or we have, if I square both the terms, we have m square is equal to c square, m0 square, c square, and we have c square minus v square. Now, or we can write m square c square minus m square v square, that is equal to m0 square c square. Okay, now if I differentiate both the terms, then we have m square, if I differentiate both the terms, we have 2m c square dm minus 2v m square dm v dv minus, if I take this minus as common, this will become plus. Now we have 2m v square dm, that is equal to, now m0 is mass at rest, that is constant, and c is the velocity or speed of light, both are constant. So m square c square is constant. Now differentiation of constant is always 0, so I can put here 0. Okay, or we have 2m c square dm minus 2m square v dv plus 2m v square dm, that is equal to 0. Okay, now if I divide both the terms with 2m, because 2m is, well, always is common of this term. So if I divide by 2m, so right hand side will remain 0 and left hand side will be c square dm minus, if I to divide 2m, then it will become m v dv plus v square dm, that is also equal to 0. Now we can take v as common in this term, then we have c square dm minus v common, we have m dv plus v dm, that is equal to 0. Let's put this equation as equation number 1. Okay, now we have this equation, E is equal to d of mv dot dx. Okay, so now from this equation I would like to write this equation here. E is equal to d of mv dot dx, or we can write E is equal to m dv plus, if I differentiate this term, then it will become m dv plus v dm times dx. Okay, so so I need to write dt here also, because the rate of change of momentum, I said I made some mistake. So rate of change of momentum with respect to t, that is equal to force, in times the distance, that is equal to the energy. So I need to put here 1 by dt, so that denotes the rate. So this dt I am going to put here. Okay, now I have dt as a denominator and numerator is dx. So dx dt, that is equal to velocity v. So if I replace this dx by dt equal to v, then we have E, or E is equal to v into, simply putting dx dt equal to v. So v into m dv plus v dm. Okay, let's say this is equation number 2. Okay, now if I compare equation number 1 with equation number 2, I can put this thing, I can replace this thing with E here. So these two are common here. So I can replace E to here. So I have, or I can write from equation 1 and 2, we have I can put here c square dm minus, this term will become E, that is energy, that is equal to 0. Now if I simplify this thing, okay, I have E, that is equal to c square dm. Okay, now if I integrate this term, okay, I have E, that is equal to integration of 0 to m, because m is a variable, c square is common, so c square will go outside, m dm. Okay, so that is, if I integrate, it will become m c square. So E, that is equal to m c square, that is mass energy equivalence. This is one of the famous equation of Einstein, where we can see that mass can be changed to energy and energy also can change to mass, and what will be its value? the relation is equal to mc square. Hope you have enjoyed this video. If you have anything, then please write to my comment box, and thank you very much.